Energy is civilization. Would you say it's true in your lifetime's experience that all the stuff in your life, cars, computers, phones, and all that, have generally been improving over time? Well, I think most people would agree that the answer to that is yes. And that has been true only for eight prior generations. And here is the reason. This is the GDP of the world over the last 2,000 years. And what you can see here is that GDP of the world was essentially flat up until around 1750. And in 1750, the Industrial Revolution kicked in with the steam engine. And it was this, more than anything else, that caused the explosion in global GDP. Because at this point in time, we were able to harness a far greater amount of energy than was ever done previously. Yes, as Václav Smil has pointed out, in prior generations, horses, oxen, and so on had been used to increase farming efficiency and production. But the problem with that is the horse also requires energy, and it more or less doubled the amount of agricultural land required to feed the farm animals to do the farm labor. So while it was an improvement, it was not that great. That was not true with the steam engine. With the steam engine, our ability to use energy exploded. Now, fusion is very difficult, and if we're going to decarbonize the economy and get rid of all that coal, oil, and gas, why don't we just use solar and wind? I mean, the costs have been coming down. It seems to be going well. Why not? Well, this is the actual picture, and this is from our World in Data, which is an offshoot of Oxford University. And what you can see here is since 1800, the amount of energy use has exploded and it has never decreased in any decade. What you see at the top here is we use about 174,000 terawatt hours of energy. Out of that, about 137,000 is fossil fuel. Solar and wind is about 5,300 terawatt hours, and these figures have already been adjusted for the end use case by what's called the substitution method. So no, there's no big boon to be got out of these numbers by swapping out fossil fuels and creating electricity directly from solar and wind. And the total storage capacity of the entire world right now, if we put all the Teslas together, put all the Powerwalls together, took every battery out of every cell phone, did it all, it's about a terawatt hour of total battery capacity. So storage is a major issue, obviously, for renewables. This is the same data in the last 10 years. And what we can see here is that since 2010, there has been a major increase in wind and solar. It's up nearly 5,000 terawatt hours. In fact, almost all the solar and wind that has been deployed worldwide has been in the last 10 years. Biomass, this is mainly wood and also dung in the developing world, has decreased. Hydro has increased, but almost all of this 1,500 terawatt hours is due to the Three Gorges Dam in China, and we have run out essentially of large hydro projects. Nuclear, disturbingly, has dropped, even though nuclear is a zero carbon energy source. This is owing to Fukushima and the decision by Germany to eliminate nuclear power from their grid. However, in the last 10 years, fossil fuels have gone up by 15,000 terawatt hours, almost three times the increase of wind and solar. This is very worrying. And if this seems to contradict statistics you have heard, I will point out that these are the global numbers. If you look in the round at certain countries like the United States or California or England, the figures are far better. But that's largely because we have outsourced the problem of manufacturing to the emerging market countries. So just because we have shifted it abroad doesn't mean we have eliminated it. And there is only one way to do whole cost accounting on this, and that is to look at the entire global energy demand. And these, unfortunately, are the real numbers. So the total increase there is 21,000 terawatt hours, 15,000 in the last decade, all fossil fuels. And the takeaway from that is that renewable energy growth is not even keeping pace with the fossil fuel energy growth. So what this tells you is we have a mountain to climb here, folks, and we are nowhere even close to solving this problem. So we need to try everything. And we particularly need to try every form of energy generation that could potentially solve the problem. And that means trying nuclear fusion in every possible form.